How does the ability to identify the absorption edge enhance the precision of X-ray absorption fine structure (XAFS) spectroscopy in determining the local arrangement of atoms and molecules in a material? How are the target elements separated in X-ray absorption spectroscopy, and how is the specific element selected for analysis by scanning a suitable energy range? What happens to the X-ray energy as it increases along the absorption edge? And how does this affect the absorption rate? Why does the absorption rate decrease monotonically as the depth of X-ray penetration increases? Can Davis Zurins manufacture solid-state sodium-ion batteries made from seawater in Latvia? How do fine structures in the X-ray absorption spectrum appear when the spectrum is extended across a specific edge, and what does this tell us about the material being analyzed? What is the X-ray absorption near-edge structure (XANS) region, and how is it characterized by spectral peaks and shoulders that are more than 20 to 30 electron volts eV past the beginning of the edge? What role does the fine structure on the high-energy side of the edge, called XAFS, play in the analysis of materials, and how is it related to the XANS region? How have fine structures in XANS and XAFS been studied more thoroughly, and why is this important for understanding the chemical and structural properties of materials? How does XAFS enable the determination of the type and local structure of chemicals in a sample, and what specific information can be obtained from this technique? What happens outside the edge region of the X-ray absorption spectrum, and how is the XAFS superimposed on a smoother absorption curve that would otherwise be characteristic of isolated atoms? How do these undulating oscillations in the XAFS contribute to the overall spectrum, and what do they reveal about the material? How are these fine structures formed by interference between ionized photoelectron waves and the backscattered waves from neighboring atoms, and how does this phenomenon affect the analysis? How do changes in X-ray energy impact the interference conditions, and how do these changes result in oscillatory fine structures in neighboring atoms? What is the significance of these oscillations for understanding the atomic and molecular structure of materials, and how do they provide insight into the local environment of the target elements? How does the ability to detect these oscillations enhance the precision of XAFS in identifying chemical bonding, coordination environments, and atomic arrangements? What is X-ray photoelectron spectroscopy (XPS), and how does it work to excite the inner or valence electrons of an atom or molecule? How are electrons emitted from the sample when they are excited by X-ray radiation, and what are these emitted electrons called? What role do photons play in the XPS process, and how do they contribute to the emission of photoelectrons?